So good afternoon, everybody. I'm Rob Akroyd, and this is my colleague, Clowes, and we're presenting on ArcGIS Velocity, which is a new cloud-based solution allowing you to process and analyze real-time data, as well as carry out big data analytics. So all this has been possible up until now on-premise using ArcGIS Enterprise with Geo Event Server, and with Python, you could write code, schedule it in a scheduled task, or write it in a notebook. And with GeoAnalytics Server, you could carry out big data analytics. Now, all those required you to install software, have your own infrastructure, maintain that infrastructure, upgrade the infrastructure, upgrade the software, and support like Python code, for example. Now, those are still great solutions to have, but what we're talking today is about ArcGIS Velocity. So what is ArcGIS Velocity? So it was released February last year. It allows you to ingest and work with a wide variety of real-time sensor data, and it extends your ArcGIS Online subscription without the need for any developer activities to configure any of these feeds. So as well as allowing you to ingest the feeds from the APIs, it's also an end-to-end system for analysis, allowing you to analyze the data as it streams in from these IoT platforms in real time, in near real time through scheduling of those tasks, and over time against repositories of data collected over time. And you can also take action as a result of your analysis, so not just storing the data that the rest of the ArcGIS system can use, but also notifying people when certain conditions are met, such as sending them emails or text messages like we saw in the plenary earlier. So there's loads of use cases that we can think of where this might be useful. So from tracking your personnel, knowing where they are, making sure they're not in danger areas, known danger areas, optimizing resources when responding to incidents, allocating the right staff to the right places at the right time with the right skills, tracking entities and assets such as ships or containers, vehicles or packages or parcels, guarding against threats to infrastructure through monitoring rainfall, temperature, or river levels. In control rooms, responding to incidents in a timely fashion, so sending the nearest traffic officer, for instance, to deal with an incident on the road network. And also things like air quality monitoring, receiving information directly from those air quality monitors to understand the impact on public health, as again we saw in the plenary earlier. And in the future, dealing with connected car incoming vehicle data. So how does it work? It extends your ArcGIS Online subscription, as I said, and it complements IoT platforms by enabling that sensor data to be brought directly into the ArcGIS system. There's a huge variety of sensors in the field that have been connected up continuously to different IoT platforms and vendor APIs. And ArcGIS Velocity can subscribe to or query those APIs directly without the need for any developer activities. Equally, those sensors can send their data and push it directly into Velocity through endpoints such as a HTTP receiver or a gRPC endpoint, which is just natively out of the box with ArcGIS Velocity. Now, when you configure ArcGIS Velocity, you end up with some new item types in your ArcGIS Online organizational subscription. And these are feeds, where you actually configure how you connect to the feed and the parameters for that. Real-time analytics allow you to build models that implement the logic of your workflow. And with the big data analytics, you can analyze repositories of data that you've collected over time. Now, both those sorts of analytics have the ability to write out geospatial content as their output that you can then use in the rest of the ArcGIS system. So you can create things like stream layers, feature layers, map image layers. And then you can then use those in your applications and in your dashboards, access them through APIs, or in desktop applications such as ArcGIS Pro to gain further insight and situational awareness. So now I'm going to talk you through a simple problem where we can use Velocity to analyze where buses are bunching. It's a common problem for people who travel around a lot on the transport network. So this is the situation. So your bus is supposed to have a service that's scheduled to come every 10 minutes, but yet you've been waiting at the bus stop for 30 minutes already. And then the bus turns up, so you get on the bus. But then, as expected, still the next bus turns up, and still does the next bus turn up. And then, unbelievably and inexplicably, all 3 buses leave at the same time, right? So that's not just a very poor passenger experience because you've got a massive gap in the service. You've also got 2 empty buses burning fuel following a full bus round a route. So I'm going to hand you over to Hayley, who's going to demonstrate through ArcGIS Velocity how we can track those buses and analyse in real time where they're bunching together and potentially update a bus control room operator. Hayley.
Thanks, Rob, and good afternoon. So here we have a real-time analytical dashboard displaying live bus tracking locations across the Greater Manchester area. The live buses are visualised as arrows and are orientated to their direction of travel. Buses that have the same service number and that are travelling in the same direction along their route within close proximity to one another are classed as bunched buses, so for instance the 192 outbound here. These bunched buses are visualised in red arrows, whereas the non-bunched services are visualised in blue. And you'll notice that the bus locations are updating every few seconds as the live feed from ArcGIS Velocity comes in. These stationary green zones represent the major bus depots across the area where buses congregate between services, and the congregated buses are visualised as grey dots. Here, buses idle, and I've not conducted any bus bunching analysis here. All of these data types help us to gain situational awareness and understand and monitor our assets in real time, and this is similar to what many people have been leveraging in GeoEvent. But before I go into further detail about the analysis being conducted here, let's first get started with how to create a feed of our own, then create our own real-time data analytic, before moving on to how we can use and communicate these data outputs to better understand our dynamic world. So to begin, I'm going to look at how to create a feed of a live data source. This is a wizard-like user experience designed to help you bring in your data successfully every time. So first, we need to choose what type of feed we want to create. The different feed offerings mean we can connect to external sources of observational data, such as Internet of Things platforms, third-party APIs, data providers. In this case, I'm going to bring in the open bus data. This is from a poll to a HTTP endpoint. So my first step is to provide the connection information. And here, ArcGIS Velocity will retrieve that stream of data and derive its schema. So here, I want to derive my route element at vehicle activity, and this is to retrieve the attributes from this section of the data. I also want to flatten my XML file to add an exemption at the extensions section of the schema, as I'm not interested in returning these attributes. So here, I can make changes to any of my field types or field names, or get rid of any fields that I'm not interested in pulling into my data feed. But here you can see some of my field names are really, really long, and that will make it really difficult to use these. So I can rename these here for easier use later on. And I've got a copy here where I've renamed my fields. The next step is to input the key spatial and temporal information. So in this case, information about its geometry, which is singular XY fields. And you'll notice that ArcGIS Velocity has automatically read the schema and auto-populated these fields. Next is date information. So in this case is a singular date-time field. And then finally, a tracking identification number. And this is my bus vehicle reference number. Next, you can control how frequently ArcGIS Velocity will query the data. And then the final step is to give this a name. So I'm going to call this my bus feed. Once complete, this will begin to run in the cloud, and ultimately what that means is there's no need for additional infrastructure or systems. This is all running directly within your web browser and then can be pulled into other areas of the ArcGIS system. So let me bring that into a web map now. So here is my stream layer visualized in a map. You can see that this feed is updating every few seconds, and I could choose to visualize this as this is one of the newer item types in the ArcGIS system. As soon as the API request is made, the data is fed back, and my data on the map will update in real time. And this is the same feed that is powering my dashboard. But what's unique about ArcGIS Velocity is that not only can you harness the feed at face value like I'm doing here, you can also perform real-time analytics on the fly. So next, we're going to look at how to create our own real-time analytic, which in this case is our asset monitoring workflow. Here, we're going to identify where buses are bunching within our network and operating unsustainably. And the factors that we're going to consider is proximity of services on the same route, and then defining the areas in which we want to monitor. So for instance, excluding buses idling at the depots. So to begin our analysis, I'm going to bring in our data feed. And this is a replica to the one I've just created. Here, I can create a name for our analytic. So I'm going to call this bus bunching. So here I have the option between two different user experiences. I have the workflow view, which you can see here, or I have the model view, which is very similar to Model Builder for anybody that's familiar with ArcGIS Pro. So my first step I'm taking is to reproject our data to British National Grid. And now I want to identify where buses are bunching on our network. So to do this, I'm going to create a new field where I can take in our bus route number along with our direction of travel, so whether that bus is traveling inbound or outbound along our route. I'm going to call this field our service number, and this is going to return a string. In here, I can use a very simple arcade expression to add the bus number with the direction. And here I've joined them together with a small dash. Let me apply those changes. And now I've created a new field with our service number. And now I'm ready to identify where the buses are bunching within our network and where our buses are within close proximity to one another. So to do this, I'm going to use the Calculate Distance tool. And here I'm going to use our feed as both the target and join inputs, as I want to dynamically georeference our buses against one another. So I'm going to create a 200-meter buffer around each bus. And then where our buses bunch, I want to check that the service numbers match. So I'm going to use an attribute relationship to target our service number attribute. And the final step of this process is to apply our join time window. In this case, I'm going to create a 1-minute join time window, and this is the buffer window for which historical data is stored within ArcGIS Velocity to conduct our calculation against. Now I've applied those changes, in the schema, you'll notice that there's an additional field called distance to feature, and this has been populated for any buses that meet our criteria and that are bunched. And although I could use this numeric output to determine whether our buses are bunched or not, I'm actually going to create a new field to clearly return a bunched or non-bunched result. This field is going to be called bunching and will also be a string. So here I've prepared a very simple arcade expression to check whether the distance to feature field is empty and to return a not bunched or bunched result based upon that. Now, the next key factor of our analysis is that we only want to highlight the buses that fall within our monitoring zone and not look at any of the buses that idle at the depots between services. I've used the Sources tool here to bring in a static polygon feature layer, which I can use to filter my bus bunching analysis so far. So here I'm going to use the Filter by Geometry tool, and I'm going to add my feed as the target feature and my polygon layer as the join feature. And this will return the buses that fall within my monitoring zone. So where these intersect, I'll return buses. This could also involve any areas of known bus congregation on our network. So for instance, areas where there's traffic lights or in city centres where a lot of buses congregate, but that is not classed as bus bunching. The final step of our analysis is to create our output. This could be to a stream layer, feature layer, or an alternative web or messaging service. I'm going to return a feature layer, and I'm going to call this my bus bunching output. So once I've done this, I can start my real-time analytic, and this will begin to run our analytic within our web browser to return our output, which can then be used to leverage in other areas of the ArcGIS system. This could be to power a 3D digital twin model or to provide context to our ArcGIS asset monitoring dashboard. So let me tab over to my complete analytic, and this is the complete analytic that is powering that dashboard that I showed you at the beginning. So here you can see I've got an additional filtered output that shows the buses idling at the depots, and I've also got another real-time data feed that's being processed and analysed to provide more contextual traffic information. But the final step is how we can process and harness these outputs to power our dashboards. So let's get back into that. We can choose to monitor only the buses that are bunched within our network in order of priority and proximity. We could even use the bus ID to prompt alerts to halt the drivers temporarily and update service information online. This can be used to ultimately provide a more sustainable service and stop that second bus running with little to no passengers on it. We can also bring in other live traffic information, as you can see here. So I can use this traffic incidents Waze data to see where buses have passed through any areas that incidents are currently occurring. So here I can see that the 42 inbound passed through a road closure area. And here I can see that the 365 inbound also passed through a road closure area, but that bus is currently bunched. So we can begin to understand why some of these bunching issues are occurring. So hopefully you can see just the beginning of how ArcGIS Velocity can be used to bring in real-time capabilities as a service to the ArcGIS system within the cloud. It's hosted and managed for you so that your live data consumption and analysis is easier than ever before, and that your understanding of the dynamic world can evolve with new data. Thank you for listening.